All right, so welcome all to this unexpected video where we'll be talking about evaluating fill rate given a replenishment policy. We'll look at what will your fill rate be given a replenishment policy, and how will you calculate replenishment policy given a particular fill rate. So we did that with cycle service level in the previous video. We'll do the same thing with fill rates in this particular video. So remember, cycle service level is a probability that you'll be able to uh, satisfy all customer demand this replenishment cycle, as opposed to that fill rate is just talking about what fraction of customer demand will you be able to satisfy it with the product on will you be able to satisfy with the product that you have on hand, right? So to calculate fill rate, we also need to calculate the expected shortage per replenishment cycle. So that's how much we are not able to satisfy. So given an expected shortage, which is the average units of demand that are not satisfied from inventory in stock, we can calculate the product fill rate as 1 minus the expected shortage divided by the whatever your cycle inventory is, right? So and so that's how the fill rate is calculated. So you can actually do the calculations based off of the usual way you do it, and then this is the formula that you would use if you are doing it for the normal distribution. So this is true for any distribution, where capital F is the cumulative and little f is the probability distribution, and this is how you calculate the expected shortage for the normal distribution case, right? So again, let's go back to the example that we were looking at before. So the lot size is 10,000. So every time you place an order, you order for that. So we know that demand during lead time is 5,000. Standard deviation is 707. So 0.11, whatever we have. And then if we set our reorder point at 6,000 and our safety inventory is 1,000, we can calculate the expected shortage, and from that we can calculate the um, fill rate of 99.75, right? So that's how we can calculate that. So let's quickly do that calculation again. So let me get rid of the sheet. Call cycle service level. So let's do fill rates, right? So let me copy all of that over. Okay. So if reorder point is known, so if reorder point is 6,000, right, then we can calculate the fill rate. So how do we calculate the fill rate? So we can use the formula that's there. The formula for that is, so it'll be first is the safety inventory. We didn't calculate that, so that is the difference between reorder point and ending lead time. So safety inventory is 1,000. So with that we can calculate the fill rate. So fill rate is minus 1,000 times 1 minus norm dot dist of the ratio of so if you look at this formula, there's the ratio of safety inventory and standard deviation. That's the important piece here. So you can actually calculate that separately and then use it, or I'm just gonna do the ratio of safety inventory and standard deviation of demand during lead time. And right. One second. Yeah, so 0, 1. And then you can either use true or false. Either way is fine. So I'm just gonna close that. So that's a normal distribution value. That's the first part of the formula. The second part of the formula is sigma L times dist, right? Again, this time we do this ratio of safety stock divided by 7, right? And this time we have to do false because it's a probability mass function that we want. So again, instead of doing false, I'm just going to say 0. True or false, 1 or 0, it's the same thing. And so that's the value. So we have to, sorry, this is the ES, let me round this to 0 decimal place. So this is the expected shortage. You know what? It is the expected shortage. I'm going to keep the decimal places. It's fine. So this is the expected shortage, and using the expected shortage, we can calculate the fill rate. So fill rate, so we know that capital Q is 10,000. We already calculated that, right? Based on the EOQ formula. So fill rate will be 1 Q minus that divided by Q, give you 99.75, right? Approximately. So I'm going to make it a percentage with 2 decimals. So fill rate is 99.75%. So we'll be able to satisfy 99.75% of customer demand this particular replenishment cycle, right? So this is how you calculate fill rate given what your safety stock and reorder point are. But again, like we know, we cannot calculate. We usually set the cycle service level or fill rates and then calculate safety stock based off of that. But here, because the formulas are so much more complicated, we cannot actually directly calculate the fill rate based off of the formulas, because the formula for the ESC is pretty gnarly. So what we have to do is we have to use a tool in Excel called GoalSeek. It's pretty straightforward. It's not very complicated at all, right? So we already have all the formulas written out as we need to do them. So so evaluating the safety inventory for a given desired fill rate, we'll have to use the GoalSeek. There is no simple equation for the SS. So because if you look at this, the safety stock is within the probability distributions, and the probability distributions are extremely complex values. So if we want our, say for example, if we want our fill rates to be say 97.5%, then our expected shortage should be 250 units, right? If our expected shortage is going to be 250 units, then we have to calculate the cycle service level, a safety stock based off of that 250 units, right? So let's see how that calculation is done, right? So so this is the formula for the ESC, and the formula for this is based off of that. So if let's replicate this. So we know that capital Q, we don't have to write it exactly the way they did it. So we know that capital Q is 10,000. We know that DL is 5,000. We know sigma L is 707, right? So if we want our desired fill rate to be 250, so again, how do I calculate the desired fill rate to be 50? So let's say that we want our fill rate to be 0.975, right? So we want them to be 97.5%. So that's what we want our fill rate to be. That's what we want to do. So if that's the case, we can calculate that our ESC. So let me insert a row here. Call it calculate fill rate from ROP. So that's the first calculation that we did. Now let me so here we are fixing the fill rate. So once the fill rate is fixed, we can calculate the ESC, right? So the ESC, so if our desired fill rate is 97.5%, we know that we can calculate ESC of 1 minus fill rate times the value of Q. So that's how you calculate the fill rate. So it will be 1 minus the fill rate times that number there. So that's right? So these calculations are the same; they're not going to change. So we want our expected shortage. So if our fill rate is 97.5%, our expected shortage is 250. Then what should the safety stock be? So to calculate that, we will have to say that the formula for the safety stock. So desired fill rate is 250, safety stock. We have the formula for this. I'm going to put that. So let's add an extra column here. I'm going to call this the desired fill rate, right? So desired fill rate, this the one that's going to be 250, right? And here the formula is going to be the same. So I'm going to go to data and I'm going to go to, I think it's what if analysis, yeah, goal seek, right? So we want the value of this cell. We want the value of this cell to be equal to 250. So let's say. Fine. So we want the value of this cell here. So we want the expected shortage to be exactly equal to 250, right? So that's what we want to do. And we want to do this by changing the value in the cell of safety stock. So we want to try different values of safety stock to see how we can set the value of expected shortage to 250, right? So once you do this, because it's only a single variable, it'll try different values and figure it out for us. Okay, that's weird. Yeah, it's a problem with doing it on a Mac. Sometimes it just. So we want the value. Oh, I'm so sorry. So we want the value of this cell here, right? We want this to be 250. And that by changing the value in this cell. No. For some reason it's not able to find the solution, but it should. So it really should. So we say that the value of in this case ASIC, so you want the actual value of ASC, so you write the same formula that we wrote before, right? So it's the same formula that we wrote before. I think I messed up. Yep, that should be that. Okay. Okay, yeah. I mean, I wrote down 1000 here instead of actually referring it to this 1000 here. I think that's where I messed it up. Yeah. Okay. So we want to set this cell to 250. We want to do that by changing this cell. There you go, 69 point. We can reduce. So 67 is the safety stock. That is the desired safety stock. So if you have 67 as a desired safety stock, you can calculate the reorder point as this plus that. So with this, we'll get a fill rate of 97.5%, right? Okay. So that's that's basically the idea. So given given reorder point, you can calculate fill rates. Given fill rates, you can calculate reorder point, but it's slightly more involved. You have to use the goal seek function, right? That's pretty much it, right? So again, so this video is getting long. So in the last video, what we'll look at, so last video of this week, we will look at what happens when the lead time itself is uncertain, right? So what if the lead time, if there's uncertainty in lead time, right? That's in the next video, right? Take care.